Hello and welcome back to a new video. Today we are here at Live Coding with Rayzn, the title of the thing. We are doing ropes today, yes, and that's a rope, right? This is a rope. What we're supposed to be doing today is just creating this amazing system. And since I have already tackled something similar, which we're going to take a look at before making the ropes, so that's a rope, right? So we'll generate a set of points between point A and point B, and then, well, the set of points will have gravity will be attached between each near point. So they will do like this, and they will have a spring force that will tell them, okay, you need to be closer to this one by this distance, and there's a dampening factor to it as well. So maybe we can play with this a little bit and make a really cool rope system to use in video games, okay? How a rope system can be done, okay? First, protein drink, because I really need it. Oh, that was wonderful. Wonderful. Dive into Krita and let's start drawing, right? So, ropes. We have point A and point B, you know. So we will know the position of point A, point B. If we know this information, use a lerp. We could lerp this distance. And every time we want to set a step, for example, lerp, you know, goes from 0 to 1, right? So if we want to set a point at the exact middle, we would set a point right here, which would be 0.5 on the lerp. You know, this would be kind of for this, right? Well, 7, 8, 9, and 10. You know, each point right here, let's change the color maybe, so I can have a, you know, we're maybe looking at this point, right? So this point, for example, how would it be affected? We got this. Okay, so if you wanted to move down with you know, gravity, but you want them to be tied together, right? You want this one to be tied with this one, and with this one, right? Because you don't want them to lose, you know, their connection, right? Because if you just pull this down, right, it will need to pull down with the other ones, right? And this dot, you know, as well, you know, is affected by this one and this one. And this dot as well is affected by this one and this one. And they will be tied together by a spring force. It's going to be spring force, right? This spring force will basically how much is the original point influenced by the nearer point. Not only with a spring force, but we will as well probably just multiply this by with a damping factor, which will slowly but surely this damping factor simply, you know, reduce speed slowly. So yeah, you're pretty much going to enjoy this. Ropes are a set of points that we lerp from point A to point B. We can get all these points in between, and then we can use these points to make the rope and apply all the physics calculations to these points, tying them together by a spring force and a damping force. You know, and these points, by the way, these two big points, you know, they will not. Okay, all right, they do not move. Not move, right? Because we will use them for, you know, putting here and here, you know, have this rope kind of hanging or something or doing whatever. Oh, okay. Got rid of this. Of our drawing board. Let's save the thingy so we don't lose it. The thing needs to be placed in a hole just like this. It slides in, and that's it. It's stored. Wonderful. Yet, I would like to install or show something. So, what I wanted to show you guys is this system I have right in here. I made this thing probably kind of like 1 year ago, and it's basically I was trying to create a spline water system. Look, you can see how the other points are being influenced. Yep, if you increase the damping factor, it will settle faster. So if you increase the spring factor, it will spring much more. That's what I'm talking about, right? That looks wonderful. You can see how the waves move and everything. It's really enjoyable. The spring water, basically, the array has all these points that we can move, and the velocities of each point. You can see they have these velocities, and that's what we're updating here, right? Remember, always, as a game developer, you need to think about, oh, I need to make a rope system. Can't I get something out from something I built like maybe a month or 1 year ago, or maybe even 2 or 3 years ago? Oh, I remember I made this weird spline water thing. Maybe I can just extract some of the knowledge I have there and apply it to the ropes, because I think try to be smart and try to reduce the amount of work you're trying to deal with. In this case, we're going to start from scratch, but we may grab one of the functions. I don't know. So yeah, now you know what did I tackle last time and how did it went with the water. That's what you see. We are with Unity in our wonderful world of the rope system. I have already created a folder for the rope system. It's inside systems, rope system, and we have a scene that's the rope scene. It's this scene. Let's start straight to it. We don't have to make any adjustments to anything we had before. Scripting, mana behavior script. Let's call it rope system. Doesn't matter. We're opening that script. It shouldn't break. We have different color scheme. We have Brazer's color scheme. You know, that's just wonderful. Diaspora, if you want to know what this is. So, what does our rope system has? Okay, let's create, transform start and start point, which is going to be our start point for our system. And, well, look at that. Oh, we can duplicate now. Amazing. Now I can go here, call it endpoint. We can go as well and declare some vector 3 array of, points. And now we'll have another one, which is velocities. Rope points velocities. We're going to do it ugly. We're going to do it long. Fuck it. Okay, so we have the two arrays, right? The rope points and the rope point velocity. We'll need a float that is called spring force. Woo! Fucking it up already. So we have a spring force. We have another float, which is called dampening force. And now, let's initialize our thing is right. So, we need to know the position of start point and end point. From there on, we will need to calculate the amount of points it has, right? The details. And rope detail. So this thing public, so we can easily, well, maybe not even public, but serialize failed. These ones need to be, I don't know. Let's get the start point. Let's make start point is equal to transform dot get child 0, and the other one it's going to be endpoint is equal to transform dot get child 1. That will enable us to basically get the childs, all right, of a rope system. We create here rope system. We create here empty start point. Create here another, end point. And now rope system, we drag and drop this thing, this beachy here. And finally, if we initialize this, we should get that our rope system will go from point A to point B by number of points. So what we will need to know, okay, what we'll need to know, right? It's, so we will need to, you know, create rope. Let's create a rope. Let's void create rope, okay? We create the rope. I love the color of this bracers. I'm gonna be honest. Look at that. Wow. Create rope. First off, when we have arrays, we need to initialize the arrays. So what we know is that the number of points, or the rope detail, is basically the number of points that the rope will have. So rope points is equal to new vector free with rope detail. Sorry, rope detail, which basically initializes an array with the amount of that we have set up in rope detail. Now we need to go to rope velocities. Show it to me. Thank you. Rope point velocity is equal to rope detail. Now we have initialized both arrays, right? We could serialize the fields. We could serialize the thingies so we can easily see them. Paste this here, and we have a wonderful vector-free array serialization that we can easily access and see whether we're initializing things correctly. Now, when we have gotten the childs, we go here and create rope. We should be good to start going. So, start point and end point should be offset by given distance. I don't care really how much distance we have from... Let's do something. Let's grab these two. Let's add a component. Let's call it mesh filter, and another component, mesh renderer. We could use one of the elevator materials, but let's create a rope material. Come on, we need to do this. Rope mat. Wonderful. We grab this two, we drop this rope mat here, and boom, there we go. We can modify it now from here. We'll drop the smoothness. Metallic, we don't care. Well, it's a rope, right? Let's make it be a rope. Rope color. Oh, what on earth is this one? Cube. Wonderful cubes. I love cubes. Who doesn't love cubes? Now, endpoint should be here, right? I don't know, somewhere else, right? And this thing should be kind of in the center. As always, I set things up to be on the center. Start point here and end point here. And there we go. We have 2 points, right? Wonderful. Now let's go to rope system. Start point is the first child and end point is the second child. We have it properly set up. We have the rope points here and the rope points velocities. Okay, have we initialized them? Nope, because, well, we probably have initialized them, but rope detail was at 0, so we had 0 points. Well done. Now, correctly, we have initialized the rope points, which we have 0, 0, 0. Everything is at 0, 0, 0 because we have not added anything. But now, what we need to do for this rope to actually happen and start existing, we need to make a for loop, right? Yeah, for int I equals 0, I is minor than rope detail I plus plus. Wonderful. What do we need to do here right now? It's theoretically quite simple, right? So I is equal to the point we're looking at. New game object. Let's call it new game object, right? Let's create a new game object. Create. Instantiate. Game object, which is called, I don't know, rope point. It's equal to new game object. New game object, which will be called, I don't know, rope point. So rope point is a new game object, rope point I dot to string, and a rope point float t is equal to I divided rope detail. Yeah, t is equal to I divided rope detail, and if I is equal to rope detail, that's going to be equal to 1. Yeah, that's correctly. And now we need to rope point dot transform dot position is equal to new vector 3 dot lerp That's it. And now we can lerp from point A to point B using T. And technically, that should position our points along this spline. Okay, so let's get start point and end point. Okay. Oh, we need T. T. All right. From start point dot position and end point dot position, which are vector frees. And with that, we should technically position each rope point. Well, let's just see what it does. Let's put some prefab here. We need to serialize a field with a game object. It's going to be a debug object. So we will basically position a bunch of debug objects. I'm a instantiate because this creates a new game object that you know, and if you want to position that, but that's an empty. But I want to put a prefab, right? So I would go instantiate debug. Sorry, debug object, and with name transform parent, which is this transform. You can do it like this. Then we can say rope point dot name is equal to plus I dot the string. Wonderful. So at the end we instantiate a debug object. We call it rope point I, and then we need to position this rope point at transform dot position. You know, basically the same thing we've instantiated here. We do the lerp, we fuck it, and we basically instantiate that, transform. Okay, let's see where does it place these objects, right? Let's see if it does generate the spline in between point A and point B. We need 20 items there. Come on, problems. The variable debug object has not been assigned. It's true. It's true. Thankfully, that was my fault. So we create a new 3D object, right? So let's put a sphere. So these things will be our row paths, right? Row positions, right? We drop this here. Debug object. Okay, we have the debug object assigned. We have them. Have these rope points, but transform positions of these rope points has not changed. All of them are 0. Okay, let's look at the code. Something I'm doing wrong. Okay. My bad. My bad. Rope points. Here we need to make another one, which is transform. All right. Rope positions is equal to no transform. Transform array of, you know, rope detail. Now, rope. That's where I failed. Okay, rope positions I is equal to rope point dot transform. Okay, because it's a transform array. We need to assign the transform. Am I doing it right? I divided rope detail. Give me the result. Let's debug.log. Debug.log. Let's log the I dot to string. I need to log the T. So T. So now we will, we will add position. We close this, we have the debug.log. Let's see whether it's doing its thingy, right? It's not. Well, we are creating the objects. All of them are at T0. Actually, think it's because I haven't set a float. Rope detail -1. Now, theoretically, we should initialize this, and this thing should initialize its points along a spline. If I haven't... No, yet. I still... Oh, wait. -1, 0.95, -9. Why -1? -1. 0.6, 0.45. Okay, I don't know, let's see. Well, we've got it. We've got 20 objects from here to here. And one is the last object and one is the first object. Wonderful! Now, these points will represent our rope, okay? You know, this needed to have this parenthesis, okay? Okay, now we have the points position. That's really cool. That's really cool because now we need to play with physics and make them do wiggly woggly things, which is really cool. We are here. I've taken note about a few things in a notepad and in here. So we would need to, in terms of making the physics for the rope, first iterate over the points of the rope, get the directions, the force directions, in this case, between the nearest point and the, you know, the last and next point. And then we would apply the spring regarding to these forces. So we would scale this direction force by a spring. And then we will apply dampening to this same spring. And then we would apply the velocity result into the velocities. And then we could do whatever we want with the gravity and other stuff. We could have fun with it. Rope physics, right? So let's create void rope physics for int I equals to rope detail I plus plus. Boom, we have a for loop going on here. Wonderful. In update, we could run it in update by now. Rope physics, let's call it this way. Nice, wonderful. It's running in update. So the important thing now is that we need to iterate, which we are already doing like this. First off, let's go get directions, right? So what we know is that, so we remove the rope points and we call them just rope positions and we hold the transform. Because I remembered, you know, I realized, you know, we don't need the vector free if we already have a transform that position because that's a vector free and that already defines our positions. So we're getting directions, right? So we need to go vector 3, which is going to be direction next. Direction next is equal to, for example, rope detail. Oh, no. Rope positions I plus 1 minus, in order to get a direction, you always get the position you want the direction to point at, right? And your current position, subtracting your current position from the position you want to look at, right? So we would subtract from rope positions I. We were not playing with vectors at position. Okay, that's what I sort of forgot. Okay, so direction previous, you know, it's going to be the same, but in this case, I minus 1, right? Direction previous. Well, the previous position minus our position that we're evaluating. Now, need to go apply spring, right? Because we got direction. Get direction, apply spring. To apply spring, we need to go direction next is equal to direction next times spring force. And direction previous is equal to times the spring force. Wow, Copilot is not bad. Rope velocity is I plus equals direction next times spring force. All right, we're close to it. Times time dot delta time. Because if not, this is not a spring. You know, a spring occurs during time. And now we do the same. Just duplicate this. And we could do direction previews times the spring force times time, the delta time. So we are adding these forces. So we are applying the spring to velocities. Okay. Direction previews, this can be removed entirely. So yeah, we need to apply dampen. Apply dampen, as we said before, it requires us to subtract instead of adding, because we're not adding a spring. We're not adding, we're subtracting. So to apply dampening, we only need to multiply the rope velocities I, minus equals rope velocities I times dampen, rope velocities I times dampening force times time dot delta time. That's technically how a dampen should work. And now, like, this is our rope velocity I. So we need to apply this result to the position, okay? I mean, Raymond, wake up. It's in the morning. You need to wake up. Let's go. Rope positions I plus equals rope velocities times time dot delta time. Okay. It always happens to me. I think I'm playing with vectors, but this is a transform again. Fucking crazy, Raymond. So, apply velocity to position. So, we have this thing, right? This should theoretically apply some rope physics, without gravity by now. That should technically allow us to get some rope moving, I think. What do we do with start point and end point once we have created the rope? Do we remove them? Set active. False. Yeah, we could set active the end point. So that's set active. False. So, I mean, let's close it in bracers, I think. So yeah, let's go test this rope thingy, rope physics. For some reason, index out of range exceptions. Index was outside of the bounds of the array. Okay, I plus, oh yeah, this should equal to 1 and rope detail minus 1, because we're only looking for the nearest and, you know, the next. So if we got to the last position, we would check for the next one, and that's outside of the range, baby. That cannot happen. Okay. So yeah, that's not breaking. And if we grab a 0.0, now we should see when I raise it up that all the other ones should follow it. Oh, that's wonderful. That's kind of exactly what I wanted. And now this works as well here, this way. You can have multiple movements working here. You can see how this, wow, it's pretty cool. So that would be kind of our rope, right? They have a springiness. That would kind of be a rope. If we actually make it hang from a given position, because you can see. So what we need to apply is just gravity. It's just let them fall down, but not the 0 and the 1. Okay, so we have a basic rope functionality. Now, what we need to do is in the rope velocities, just add a gravity constant, right? So we create a vector 3 gravity. We can make it serialize field, and that can be enough. with that gravity constant. So rope, let's try it here, right? Rope velocities. No, not rope positions. Rope velocities. I plus equals gravity times time dot delta time. And that would give us gravity and the point we are evaluating. And then the next point, if this point has fallen, a little bit, the next point will fall with it because it will evaluate first the forces and then it will need to fall, right? I don't know. So we should see a rope happening. Scary Mary. Okay, gravity is 0. Gravity is 0, which is great. That was a rope in space. Boys, we have a rope. Boys, we have a rope. Oh, shit. We have it. We have it, but that's... Oh, my God. That's a rubber band. Yep. We're going to set this to... Yeah. Wow. Wait. Should start decreasing. Poor rope. We actually broke it. Okay, now it's stabilizing. It was too much for it. So yeah, this actually sort of works like a rope. Not exactly. So yeah, you can see the wiggly woggly fashion of the rope. If you want a, really tight cable, you would put it like 200. And that's a tight cable, right? So you can have a little bit more of... Yeah, look at that. That's a little better for a rope. We should limit that, right? But this looks interesting to play with. Like, I really like it. Create a 3D object. Plane. Plane of existence. 10 and 10. Wonderful. We have a mesh collider. It's going to be a static mesh. But instead of that, let's grab this gravity function. Let's make another for loop, right? Void add gravity. Add gravity before everything. So we'll go for int I. I is minor than rope velocities dot length. And now we will have fun. So now we will go here, add gravity. We run this. We have this rope. It's happening. Now let's fully polish this, right? Let's make it truly be a rope, okay? Now let's make the system finish because, we already have the basic concepts applied. Now what we need to do is create a function to draw this. So let's grab a LineRenderer component that will probably be held in rope. Add component LineRenderer because I'm hungry. And let's get this LineRenderer component assigned. So we go to renderer, void draw rope. Okay, draw rope. And now what we basically need to provide is the positions. 4. Yeah, we could go rope positions. Length -1. Thank you. Or renderer dot set points, set positions. Sets the position of all vertices in the line a vector-free array. That's wonderful. This is exactly what we're looking for. Set positions. Need to create an array of vector-frees. So vector free array is equal to new vector free array of rope detail points. We don't care. Rope detail, so points I is equal to rope positions I dot position. So now with that, set positions, we provide points. Vector free array points. Okay, it needs to be outside of the for loop. So now you go into points. So now we go here, and after we apply the rope physics, we say draw rope. What this enables us, so that's basically set the positions of all vertices in the line. That's it. That would technically create a rope. We need a material for the rope. You see, right? So yeah, we can have this to truly be a rope, right? Truly be a freaking rope. First off, we need to go here and remove the mesh renderer here. We could remove the rigid bodies of this. Whoopsie, whoopsie. Object reference not set to an instance of an object. Are we grabbing the renderer? No, we're not grabbing the renderer. Okay. Renderer is equal to get component line renderer. Thank you, Copilot. You made it faster. So now this should create the rope. Don't know what it has created. That's not looking like a rope. Renderer dot set vertex count. Set number of line segments. Use position count instead. Position count equals rope detail. Thank you. So we can set it here, render the position count equals rope detail, and say render that set positions points. Yeah, it's good to warn me, really. So yeah, we have the line renderer. Something is not... What the fuck? Yep. That's a rope. Sorry, we shouldn't make it -1 here. On draw rope. Because that's what's happening. Because I don't think I'm assigning this transform.0 right there. Like, I don't understand it. Oh, yeah, it was that thing. Whoops, it's me clicking somewhere and just goes crazy. And maybe that gives you a stiffer rope, something that you can easily just wiggle around, and it's more stiff. You can see how stiffer it is. What have we learned from here? That making a simplified rope system for hanging ropes, it's not complicated. And maybe to have the rope to just wiggle a little bit because of the wind, which is at gravity, then we would copy this. It would make here add wind. Well, add wind. And with add wind, we would do basically wind there, wind direction. So we will basically give a wind direction to this function. Let's say it plus equals, wind there, wind direction. And now they will not only be affected by the gravity, but as well by the wind direction. Rope physics, add gravity, add wind. There's something really interesting about this, that now if we just add wind and random range of, I don't know, between from 0 to 1, really, from 0 to 1. Then we will get a wind speed variable, for example. Doesn't matter. Let's make here, let's create a space here. Properties, right? Variable right here. Public float wind speed, and now times wind speed. So this will happen for each point randomly. Okay, that's kind of okay. No troubles. Random position counter, world detail, that's great. We have a wonderful day now. I don't know why, but it... Oh yeah, I know it breaks. Update. We're running physics things on update, and that's something bad. Remember always. Fixing it. Probably this will fix all the issues we've been having lately. Like, come on. Dampen yourself, buddy. Okay. Okay, that's dampened. To put wind force to 100. Maybe 200. So we can clearly see how the rope is moving by the wind. It's only being pushed in that side. Well, that's kind of something. We still need to fix the thing of collisions. I don't know how would we solve that. And should you know, collide. Wow. Sorry, it's stretching outwards. For some freaking reason. Like, kinematic colliders do collide yet, right? Yep, collision detection was discrete. Who said kinematic objects don't collide? Yes, they don't collide. So yeah, we haven't solved the collision. I guess what I would need to do is to make my own collision system. Basically create tiny spheres, detect collisions, and bounce them off based on the intersection. Well, we got something close to a rope, but it's just for sake of hanging it. Let's kind of show what these can do in a video game. You know, would be kind of our poles, right? Kind of. And you will get pole A and pole B. Let's make it real simple. Let's make it be a wonderful pole. Yay. And now we would basically duplicate this. We'll get this thing here. Oh, get this thing here. We would get this thing up 0.5. We would decrease this to 0.1. Call this electric pole. We have the electric pole. Duplicate the electric pole. Put another electric pole. Not just one, but two. Rope systems in action. Okay? Which kind of colors are poles, right? Brown. Dark brown. And what we can see in this scene, we have two ropes hanging. Wind direction. And here we put wind direction, so we can choose wind direction times 0.5. Maybe we don't care about this. We don't need to multiply by 0.5. It's the sum of the things. So we'll grab this, we'll grab that, we'll make it thicker. So you could adjust as well the gravity of the thing, how much you want it to be affected by gravity. One that has only one gravity, and one that has a lot of gravity. Oh wait, I'm not seeing shadows. You know, two-sided. Okay, that's the problem. That was the problem. Let's hit play. And we have the system. I'm really happy with this. I'm quite happy. Like, this is, well, a little bit too much. A little bit too much, maybe. So yeah, the more points you have, the more affected will the rope be. So you need to adjust the distance between points and things like that. Right, from start point to end point, it's 20 meters. We could put a point every 2 meters, which is exactly what we did with 10 points. Yeah, you can see the mesh. If it distorts a lot, you can clearly see the mesh. But you know, the cool thing about this is that you want to make the next Skull and Bones. So you can put some ropes hanging there and you know, let the boat move and the ropes move with the boat. You know, just I don't know. This is like a really cool, stupid thing that I've never done, and it's really cool. Like, I really like it. I really, actually really like it. And, well, as I said before, important thing is wind. If you add them the wind, these ropes become alive. And that's a really cool thing. That's a really cool thing, because you can, you know, it's 53 kilometers an hour of wind. These ropes are moving. These ropes are suffering the wind in a randomized order, which makes them look more like windy things. So if you go to 100, dampening is 2. 200, dampening is 4. So it's always times 2. Times 2. We could wiggle about this for quite a longer time. And that was all. That was the system for today. I think we have completed our objective. We have reasonable ropes affected by gravity. If you place this in any game, they will look like ropes. Like, really. Like who's going to complain to you? But hey, that's a rope system. That's a rope system, buddies. Hopefully you've enjoyed this wonderful video. We actually do have it. It's time to take a sip of water, because this has been a little longer than. So yes, we did it. We are great developers. We can prove to people we did it. I mean, they don't have collision though, but that would require me to, you know, probably cast a sphere around every point. Basically the next thing I would rather need to be doing, handling collision and stuff. But usually in many games, these ropes don't have collisions. They are just there for show. So if you want to make a game look, oh, just for show, just make them some ropes and tell them, hey, this is my amazing rope system, and I really like it. I'm gonna be honest, I really think it's enjoyable. And as you can see, it only requires us to really create the shape and then apply the physics of the rope physics, which are basically tying the points together. And then we would add gravity and the add wind, so you can see it wiggle about. And then the draw rope function, which basically grabs a LineRenderer, sets the number of points, and sets the points. That's it. We assign the points to the positions of the rope, and we have the simplest rope we could ever do. As I said before, hopefully you've enjoyed this wonderful journey. We have ropes now. You have been done and completed, baby. Yes. Gotta note that all these live coding challenges we're doing here will be published in a GitHub repo at the end of the year. I think it's not worth it to publish each system individually, but I guess if we make a good set of systems, maybe we can publish that great package. That's why I do everything in the same Unity project, and that's going to be everything that we have. It was not really that complicated. It simply required me to apply some basic knowledge. I don't know if you can read it here, but well, I just took note about some stuff. I'm an old folk. I write down on paper. So yeah. Have a wonderful day. It's been an amazing day, an amazing time, an amazing session. So yeah, hopefully in the next time we see each other again and we enjoy creating a new live coding session with me. See you soon. Bye.